Hello, dear friends. Let's solve Feb March 2025 IGCSE MCQ paper, component 2. The diagram shows three forces acting on object. What is the magnitude of the resultant force acting on the object? Okay, we have horizontally two forces acting, vertically one force only acting. So vertical force is 6 Newton, horizontally two forces acting. So the resultant force is towards towards right. It's 9 Newton minus 1 Newton, which is 8 Newton. So horizontal 8 and vertical 6. Now the resultant is very simple, like we can use Pythagoras theorem, square root of 6 square plus 8 square, which is 10 Newton. Option B. Which row defines speed and velocity? Speed is distance traveled by per unit time. It's a scalar, and velocity is speed in given direction. It's a vector. So option B. Which graph shows the journey of a? Oh, sorry. The graph shows the journey of a motorcyclist. Which section of the graph shows the time when the motorcyclist is stationary at some traffic lights? Okay. So in speed time graph, distance traveled is the area under the curve. So we have four sections A, B, C, D. A has some area under the curve, so it cannot be stationary. B also some area under curve, so it must have traveled some distance in A and B. In D also there is some area under curve, so it must have traveled some in the section of D. So only in C there is no area. So C is the right answer. The acceleration of free fall on the moon has 1/6 of its value on Earth. On the Earth, an astronaut's mass is measured as 60 kilogram. Which row gives the mass and weight of the astronaut on Earth and on the moon? Okay. So now weight is W equal to mg, and mass does not is not depend on which planet it is. It does not change in different places. So mass is going to be same 60 kg whether it's Earth or moon. So it can be option B or option D. Then we know that W is mg. So G, acceleration due to gravity on Earth, is 9.8 meter per second square. So W is mass into 9.8, which is 60 into 9.8, 588 Newton. So it's rounded off to 590 Newton. So actually by this time we can conclude the answer. Okay, we'll find. So it's given on moon. It's 1/6 of its value on Earth. Acceleration due to gravity. So acceleration due to gravity moon is 1/6 of acceleration due to gravity on Earth, which is 1/6 of 9.8, which is 1.63 meter per second square. Now weight on the moon is again mass into gravity, 60 into 1.63, so it's 97.8, which is rounded off to 98 Newton. Option D. Yeah. The load extension graph for a material is shown. Which point indicates the limit of proportionality? Limit of proportionality is the point after which the curve is no longer linear. So it's A. Until A, the graph is straight line, the curve is straight line, and then it's the gradient start to change. An object of mass 4 kg is moving with a velocity of 3 meter per second in a straight line. What is the momentum of the object? Momentum is mass into velocity. So it's 4 into 3 meter per second. So 12 kilogram meter per second. Option C. A tall cylinder is partly filled with two liquids which do not mix. The two liquids have different densities. A student measures the pressure due to the liquids at different depths. Which graph shows how the liquid pressure varies between positions P and Q? Okay, it's two liquids of two different densities. The bottom one will have a higher density. The top one will have a lower density. So liquid Q has higher density. Position Q is in higher density liquid. Position P is in lower density liquid. Now we know that pressure is rho GH. Now both rho and G are constant. G is constant for both the liquids. Rho is constant for each liquid individually. So if rho and G are constant, then pressure is directly proportional to H. For this proportionality, rho and G will be constant. So which is gradient if you compare it to y equal to mx plus c equation. Yeah. So whichever liquid has more density should have more gradient. So Q should have more gradient, point to Q should have more gradient than P. And pressure in Q should be more than pressure in P. So it is obviously not graph D, because pressure in both P and Q is equal. So not D. And also it is not C, because pressure is increasing linearly. But we understand P and Q are in two different places at two different liquids. So pressure in P and P to Q should vary. Some changes should be there. It cannot be a straight line. And now let's take graph A. It says the gradient is higher from P to middle of the liquid, and it is lower from middle of the liquid to Q. So it's wrong. Actually, Q is in higher density, right? So option B is right. From P to the middle point, it is increasing in some gradient, and from that middle point to Q, it is increasing with more gradient. So option B is the right answer. Higher density means more gradient. Option B is the right answer. A tennis ball with momentum 2.3 kilogram meter per second is struck by a tennis racket. The racket causes the direction of the motion of the ball to reverse. The racket exerts an average force of 1500 Newton during the impact with the ball. The racket and the ball are in contact with each other for time of 0.0024 seconds. What is the magnitude of the momentum of the ball as it leaves the tennis racket? Okay. So we have to use this equation. Ft is change in momentum. Ft is mv minus mu. The force is given as 1500 Newton and time is 0.024 second. And the initial momentum, so mu is given 2.3 kilogram meter per second. And we have to find what is the final momentum, mv. Okay. So we'll take the formula Ft equal to mv minus mu, but we have to fix the direction. See, initially ball comes from one direction and again it goes back to the opposite direction. So any one direction we have to take positive, other direction we have to take negative. For our convenience, we'll take in which direction the ball leaves, that as positive. So mv will be positive, mu will be negative. So Ft equal to mv minus mu, right? So Ft equal to mv minus of mu. Why? Because ball leaves in opposite direction, ball comes in opposite direction. So we have took whichever direction ball leaves, that as positive. So if we rewrite this equation, Ft equal to mv plus mu. Now we just have to find the mv. So we'll take the mu to the other side, Ft minus mu. So F is 1500 multiplied by T 0.024 minus mu is 2.3. So we'll get 1.3 kilogram meter per second. That's the right answer. Yeah. And if we want to do MVS minus also, we can do. But if we consider MVS negative direction, then we have to apply the force also negative, because the final momentum and the force are in the same direction. The bat exerted force is in the same direction as the ball going. So if we take V as negative, we have to take F also negative. That's what we have to do. Yeah. A car is traveling at a speed of 8 meter per second. The kinetic energy stored in the car is 32,000 joule. What is the kinetic energy stored in the car when its speed increases to 16 meter per second? Okay, when a car, we know kinetic energy is half mv square. When the car travels in 8 meter second, the kinetic energy is 32,000. So 32,000 is half into m into 8 square. If we rewrite this equation for m, we'll get 1000 kg is mass of the car. Now, what is the kinetic energy when car is 16? Same half mv square. Instead of velocity 8, we'll do 16. That's all. Half into 1000 into 16 square. So 128,000 joule. Rounder off to 130,000 joule. 8T. The sun is not the primary source of energy for which resource? Sun is not the primary source of energy for tidal. Few people think oil, for oil, sun is not the primary source of energy, but it's wrong. The reason is oil or the other fossil fuels, including coal, is nothing but just the extract and the sediment of whatever thrive under the sun, such as plants and animals. Okay, so they also belong to sun. It just happened maybe a few million years ago or few thousand years ago, but they thrive. in sunlight only. So they belong to sun. So oil belong to sun. The difference between wave and tidal is wave is mostly happening because of wind. Sometimes it's due to earthquake also, but mostly because of wind, which is created by the difference in temperature in shore and the ocean. So that also belong to sun. Tidal is the only thing belongs to moon because of the moon attraction, difference in height of the water level in earth. Yeah. An experiment is done to compare the rate of conduction of thermal energy in metal and plastic spoons. Ice cube is placed on the top uh, on one end of each spoon and the other end is heated gently. Which row has correct prediction and correct explanation? The ice cube would melt more quickly on the metal spoon because metal is a good conductor. This is the right answer. 4 students determine the efficiency of 4 different electrical devices. The teacher knows that one student has made a mistake in the calculation. Which value of for efficiency is not correct? The efficiency is useful output divided by total input into 100%. The useful output will never exceed the total input. So the efficiency cannot be 100 or more than 100. So person D is wrong. It cannot be more than 100 or 100. So this is wrong. A sample of gas is sealed in A sample of gas is sealed inside a container of fixed volume. The temperature of the gas is increased. Which statement explain why the pressure of the gas increases? Option B, mass of the gas particles increases is wrong because nothing will change. Mass will not change if we increase the temperature. Number of gas particles in the container also increase. This is also wrong because number of particles in the container will increase or decrease only if you take some gas out or put some more gas. The time between the collision of the gas of the particle increases. So this will happen only if you increase the volume. So all these three are wrong. The gas particles collide with the walls of the container more frequently. So more change in momentum is happening. So more force is exerted for the same area. So more pressure. Option A. A student does an experiment to determine the specific heat capacity of a metal block. She records the following measurements. Energy supplied is 12 kilojoule. Initial temperature is 20 degrees Celsius. Final temperature is 45 degrees Celsius. Mass of the metal block is 600 gram. What is the specific heat capacity of the metal block? Specific heat capacity, change in energy is mc into delta T. Delta T is change in temperature. So we'll rewrite this equation for C, delta E by mt. So 12 kilojoule divided by 0.6 into that gram is converted into kilogram because all the answers units are kilogram. Difference in temperature is 45 minus 20 degrees Celsius. If we do the math, then we get 800 joule per kilogram per degree Celsius. D. A metal block is left overnight in a cool, shady room. In the morning, the metal block is moved to warm surroundings. Which statement about the metal block is correct in the morning? Okay. So they're talking about internal energy. If the temp from the cool room, if we move to a warm location, the temperature of the metal block is going to increase, meaning that the internal energy is increasing. So option A is the right answer. The internal energy of the metal block increases. All the other are wrong. Temperature of the metal block increases, not decreases. So B is wrong. Convection transfers energy without the throughout the no. So it's a metal block. So it's not convection. It's due to free delocalized electrons and lattice vibration. The metal contracts. No, it expands actually. So A is the right answer. A fixed mass of gas is contained within a sealed syringe at a pressure of 100 kilopascal. The plunger is slowly moved until the pressure is 8 kilopascal. The final volume of the gas is 50 centimeter cube. The temperature of the gas does not change. What is the volume of the gas before the plunger was moved? Okay. We know that pressure into volume is constant. So P1 V1 equal to P2 V2. We just have to rewrite for V1. P2 V2 divided by P1. So if you do the math, 80 kilopascal into 50 centimeter cube divided by 100 kilopascal is 40 centimeter cube. So option B. The diagram shows the more energetic water molecules escaping from the surface of liquid water. What is this process called? Evaporation. A hot object emits thermal radiation. Which row describes two changes that both reduce the rate of emission of radiation? Okay, we have to describe the change in surface area, also in surface temperature to reduce the rate of emission. If temperature is decreased, the rate of emission also will decrease. If the surface area decreased, also the rate of emission will decrease. So both are reduced. Option D. Less surface area means less emission of radiation. Less surface temperature also means less emission of radiation. So both. Option D. The frequency of a wave is doubled. The speed of the wave does not change. What happens to the wavelength of the wave? It becomes 4 times large, does not change, doubles. Okay. We know that V is F lambda. Let's rewrite this for lambda V by F. Now, if F doubles, but V does not change, this is a condition. So let's take the new lambda dash, where frequency is just double. Okay, V isn't changing. So it's V by, instead of F, it's 2F. Now we'll just take the 1 by 2. 1 by 2 V divided by F. We know that V divided by F is lambda. So it's half lambda. The new lambda is half of the old lambda. So the wavelength halves. The wavelength halves. D. Which statement about ultrasound is correct? It has a higher frequency than audible sound and it's a longitudinal wave. Definition of ultrasound is sound wave whose frequency is bigger than, higher than 20,000 hertz. Which statement about the image produced by a plane mirror is not correct? The image produced by a plane mirror is virtual image. So option A, it says image is real. It's wrong. It's virtual. Yeah, image is upright. Yeah, image is same size of the object. Yes, the distance from the image to the mirror is same as mirror to image. Mirror to object, yes. A ray of light is incident on a boundary between air and water. Under which conditions is the ray of light totally internally reflected? Okay. For total internal reflection, two conditions. First, the wave must travel from denser medium to rarer medium. Then the incident angle should be greater than the critical angle. So the ray initially in the water is incident on the water air boundary at the angle of incidence greater than the critical angle. Option D. Converging lens is used to make an image on a screen. Which type of the image is formed on the screen? So it's a converging lens and the image is produced on the screen. So it's a real image and it will be inverted. So real and inverted. Only in magnification it will be upright. A negatively charged rod is brought near to a metal sphere. A positive charge develops on the surface of the metal sphere closest to the negatively charged rod. Why is this? This is because the electrons in the sphere are repelled by the negatively charged rod. So the electrons in the sphere will go to other end. So the positive charge will form here, negative charge will go some to other end or some other end. Option B. The electromotive force of a cell is defined in terms of which quantities? Definition of electromotive force is energy divided by charge. Energy transferred by the cell in moving charge around the circuit. A resistor of resistance R is connected to a battery of e.m.f V. There is a current I in the resistor. The power P is dissipated in the resistor. In time t, the energy transfer is E. Which expression is correct? Okay, we know power is I into V. We also know power is energy by time. So energy by time is I into V. So, sorry, energy by time is power. If E equal to energy by time is I into V, then energy is I into V into T. Actually, it's a direct formula. I don't know why I show the proof. It's okay. A copper wire of length 80 centimeter and cross-sectional area of 0.20 millimeter square has resistance R. Which length of the copper wire, of cross-sectional area of 0.40 millimeter square has resistance R? Okay, we know that R is rho L by A, and they are asking there is a length of a copper wire of which length a different diameter or different cross-sectional area will give the same resistance. So R1 is equal to R2. So we'll write rho L1 by A1 equal to rho L2 by A2. We'll cancel the rho resistivity. L1 by A1 is L2 by A2. Now we just have to find L2. Let's rewrite this one for L2. L1 into A2 divided by A1. So 80 centimeter into 0.40 millimeter square divided by 0.20 millimeter square. If we cancel out, then it will be 160 centimeter. Option D. 4 identical resistors are connected to a battery as shown. Each resistor has a value of 120 ohm. Resistor R4 is removed. Which effect does removing this resistor have on the effective resistance of the circuit? Okay, first we'll find the effective resistance of the circuit. Initially, the total resistance. So R1 is in series and R2, R3, R4, all of them are in parallel. So it's 120, each is 120, right? So 120 plus 1 divided by 120 plus 120 plus 120. So this will be 120 plus 1 divided by 3 divided by 120, which is 120 by 3, which will be 120 plus 40. So 160 ohm. Initial resistance is, total resistance is 160 ohm. Now if we remove one resistor in parallel, then the resistance is going to increase, because if you add resistance in parallel, the resistance will decrease. Vice versa, if you remove it, the resistance will increase. Now let's assume that R4 is removed. Now it will be 120 plus 1 divided by 1 plus 120 and 1 plus 120. So which is 2 divided by 120. Now this will be just 120 plus 120 by 2. Why? Because it's in the denominator, 2 divided by 120. If it comes to numerator, it will become as 120 divided by 2. So 120 plus 60, which is 180 ohm. So the effective resistance, the total resistance has increased by 20 ohm. See, the resistors in the circuit shown are identical. The reading on voltmeter V2 is 1.5 volt. Okay. Here V2 is 1.5 volt. The reading on ammeter A2 is 0.50 ampere. Okay, in the middle one. The reading on ammeter A3 is 0.25 ampere. What are the readings on the ammeter A1 and voltmeter V1? Okay, it's very easy. Ammeter in A1 is in the circuit. Okay, from there only A2 and A3 are splitting. So the total current will be A2 plus A3. So it will be 0.50 plus 0.25, which is 0.75 ampere. Super close. Now we have to find V1. V1 is the total voltage or EMF of the battery. Now we know across V2, it's 1.5 volt and they are same resistors. Okay, the resistors are same resistance. So if across this V2, if it is 1.5 volt, there is one resistor before V2, right? That also should have 1.5 volt. So the voltage across battery V1 is just voltage across the resistor 1 and voltage across the resistor 2 in A3. Since both are same, it's V2 plus V2, which is 1.5 volt plus 1.5 volt, 3 volt. So the voltmeter V1 reading is 3 volt and the ammeter A1 reading is 0.75 ampere. It's option D. Yeah. A wire is moved in the region between the poles of a magnet. A current is induced in the wire. Which direction is the wire moved? Okay. The current is induced downwards. So force is given and current is asked. So it's a generator rule, Fleming right hand rule. So it should be actually so this is the field. So this goes from left to right, and the second finger is the current goes down. So the thumb goes towards inside. So it's perpendicularly into the plane of the paper. That's a force. So the wire is moved in such a way that it's into the paper so that the current is induced in the down direction, perpendicularly into the plane of the paper. A fixed resistor is connected to the secondary coil of a step-down transformer. The transformer is 100% efficient. the variable resistor is adjusted so that the current in the fixed resistor decreases by 0.25 ampere. What is the change to the current in the primary circuit? Okay. So now we know that power is V into I in the transformer. Power in the primary coil is equal to power in the secondary coil. So it just delivers the same power. What this step down transformer does is it decreases the voltage from primary to secondary and increases the current from primary to secondary. That way it delivers the same power without changing the power. So what happens actually is, to keep the power same, it in step down transformer, it decreases the voltage from primary to secondary. To equal that, it increases the current from primary to secondary. So the current in secondary is higher than current in primary. For example, if 2 ampere is 2 ampere and 5 volt in the primary, so the total power is 2 into 5, 10 watt. Now in a step down transformer, if the current is, let's say the voltage is decreased to, instead of 5 volt, it is 2.5 volt, then the current is increased, the current has to increase 4 amps. Then only 4 into 2.5 is 10 watt. It will be same. Okay. In that way it will work. Now what happens is, the variable resistor is adjusted so that the current in the fixed resistor decreases, meaning that the current in the secondary coil decreases by some amount, 0.25 ampere. For this 0.25 ampere, the primary coil will give only less current, right? Because we understand current in secondary coil is higher than primary coil. So if you decrease current in secondary coil, the current in the primary coil will not decrease more or equal than this. It will always decrease less, because maybe if it is only 0.1 ampere there, we'll get here 0.25 ampere. So if it decrease, it will decrease less than 0.25 ampere. So option B. An electrical device changes the voltage of an electrical supply from 240 volt AC to 20 volt AC. What is this device? Just the answer from previous question. It's a transformer. An AC generator is set up so that the coil of a wire is perpendicular to the magnetic field. The coil of wire is rotated slowly to produce an alternating electromotive force. A graph of the induced e.m.f against the time is plotted as the coil rotates. Which section of the graph represents a rotation of 3/4 of a turn? Okay. Now, let's say this is a magnetic field and this is the initial coil position. Now, for 3/4, okay, why I put coil in initial position as vertical is, in the graph we can see O is 0. So, only if it is vertical, then it will be 0. So, this is first quarter. So, it will go to P. This is second quarter. It will go to Q. Now, this is third quarter. It will go to R. So, it's 3/4. So, section of OR is 3/4. Option C. Uranium nucleus 92-238 decays to form thorium by emitting an alpha particle. Thorium decays to protactinium by emitting a beta particle. Which row gives atomic number and mass number of this isotope? Okay. So let's write the equation. It decays to thorium by alpha. So 92-238 uranium U is 90-234 thorium plus 24 alpha. Okay. Now again, it changes to Pa by emitting beta particle. We know that beta is -1. So the proton number has to increase 1. No change in the mass number. 234 remains same. Only the proton number 90 increases by 1 from thorium to this Pa -1. So atomic number is 91 and mass number is 234. Option C. Yeah. Which row shows what happens when a nucleus decays by emitting a beta particle? When a beta particle is happening, it happens because of excess number of neutron. So one neutron changes into proton by emitting an electron. Option A. Which Precaution does not always reduce scientist exposure when working with the source of ionizing radiation. It's A. Ensuring the scientist only works with the source of radiation that have a long half-lives. So it's wrong. Increasing the distance between the scientist and the source of radiation, yes, it will prevent it. It's a precaution. Limiting the time for which the scientist handles the source of radiation, yes. Also, it's also prevention. It also reduces the risk of radiation affected. Placing a lead shield between the scientist and the source of radiation, yes, this is also precaution. The lead will absorb. Only the scientists work only with with sources of radiation that have long half life. It's more danger actually. The long half life means it will decay for literally forever, and yeah, bad things will happen for the person who's exposed to this radiation. A detector is placed near a radioactive isotope and records a count rate of 700 counts per minute. The half life of the isotope is 8 minutes. The average background count rate is 60 counts per minute. What is the count rate measured by the detector after 16 minutes? Okay. So initial count rate measured by the instrument is 700 counts per minute minus the background radiation, it will be 640 counts per minute. Okay. After 16 minutes they are asking, meaning it is two half life. 16 minutes is two half life. So first we have 640 count per minute. From this, one half life is half, which is 320. In the second half life, another half will be gone, so which is 160. But this will be not shown in the instrument. It will be shown plus the background radiation. So 160 plus 60, which is 220 counts per minute. Option D. The nucleus of an isotope of nitrogen N absorbs a neutron, then it decays into an isotope of carbon C and emits X. What is X? Okay. Now let's complete this equation. So in the numerator we have 114, this side 14. So X should be 0. No, no. X should be 1 because this side 1 plus 14 is 15. 1 in neutron plus 14 in N. So it should be 15. This side it is C 14. So X should be having 1. Down it is 0 plus 7. Here it is 6. So it also have 1. So it's 1, 1. So 1 proton, no neutron. Okay. Remember, top 1 is proton number plus neutron number. So it's just 1 proton. That's why it's 1. So only 1 proton and no neutron. So what is a proton? D. The graph shows how the strength of the Earth's gravitational field varies as the as the distance from the Earth's surface increases. Okay. Which row describes the effect that it has on the mass and weight of an object as it's moved further away from the Earth's surface? We know that weight is mass into acceleration due to gravity, and the mass does not change. So mass of the object unchanged. So it's either C or D. And as we move away from Earth, the distance increases, the strength of gravitational field decreases. So the weight of the object also will decrease. So option C. A student plots a graph of the speed of different galaxies moving away from the Earth against their distance from the Earth. Okay. Using the best straight line shown on the graph, what is the value of the Hubble constant H naught? Okay, this is a graph between speed and distance. So Hubble constants, we know that it is speed divided by distance. So there are multiple speed and distance points are noted down, and there is a trend line. So if you find the gradient, this will give us the Hubble constant. Okay. So for gradient, we need 2 points. I'm going to take these 2 points. 1 comma 2 into 10 power 7 and 0 comma 0. Okay. So because if you look at the point, it is easy to plot. So there is one point here and another point is 0 comma 0. And delta V by delta D is Hubble constant, change in velocity divided by change in time. Yeah. So if we take 2 into y2 minus y1 divided by x2 minus x1 method, 2 into 10 power 7 minus 0 divided by 1 into 10 power 25 minus 0. Just y divided by x, that's all. So the best we are getting is 2 into 10 power minus 18 second inverse. That's Hubble constant. Yes. Yeah. Okay. Bye bye. See you next video.